Welcome back, everyone, to theCUBE. Here at theCUBE's New York Stock Exchange studio, of course, we have our Palo Alto studio connecting Silicon Valley to Wall Street. Technology is the market, and the NYSE Wired program and community really is highlighting the leaders on the frontier, making it happen. Scott Morton, the founder, is here in theCUBE here. Thanks for coming on, appreciate it. Revel's his company. He's built rockets, he's an engineer, he's got founder of a company. Scott, great to have you on, appreciate it.
Great to be here.
First, let's get into what your company does, because you have gotten here through building things. You're building, operating, and you're investing in your business right now. And you've also been a builder and engineered large-scale systems, rockets, tools for SpaceX. Talk about what you guys do, then we'll get into some of the cool things happening.
Yeah, sounds great. So Revel modernizes the software that tests and controls complex machines. So think like if you're building rockets, jet engines, satellites, nuclear reactors. Revel would be the software that tests and operates those systems. Prior to Revel, the tools available date back to the 80s and 90s. This is like pre-Windows 98 era software. I think the reason this happened is, the age of the internet started in, kind of the 90s. All the best software engineering talent went to go work on the internet, and kind of the software for hardware really languished over that period.
You've done a lot in your since you were a kid. Talk about your fascination with building rockets and getting into the deep tech. I mean, you've been in deep tech for a long time.
Yeah, 9.5 years at SpaceX. Had a great career there. Yeah, it was an incredible journey. But yeah, prior to that, so I grew up in Wisconsin. I was a huge Lego builder. I had a whole Lego city in my basement, even with a space station. Moved on to engineering and did an undergraduate in mechanical engineering. Ended up in a robotics lab and worked on designing, machining all the parts and constructing these robots. But the big problem I had is I couldn't actually write the software, and so ended up going for a CS master's, so computer science. And learned how to code. Then moved on to SpaceX and basically saw kind of the same exact problem at a much larger scale. SpaceX had all kinds of tools. I ended up working on the infrastructure for Starship, actually, and kind of the same thing I just mentioned. We looked at all the different options, and everything dated back to the 80s and 90s, and we just decided, the best thing to do is to build it ourselves, because we could see what was possible, like the discrepancy between the technologies available and what we could build versus what was commercially available we could buy. And so Revel came about. We were like, I guess my big idea is, what if there's a company devoted to delivering the next generation of these systems? How good could we make it? We could also, all the other companies out there building complex hardware systems, they basically have to reinvent the wheel if they want to have something good. And so the idea behind Revel is, let's go solve this once and for all, and make it available to all the other companies out there taking on these incredible challenges.
It's the best time to be an engineer right now. If you look at the market, what's happening at the supercomputer level, you're seeing advances in digital twin technology. Hardware is back. It never went away, but now you have much more accelerated innovation around the relationship between hardware and software, an area you're playing in. There was an event here at the NYSE, the Space Tech event. We had a lot of folks come in here, a lot of PhDs. They're all talking the same thing. The tooling is getting better super fast. They're probably a lot of your customers. Take us through this hardware renaissance that's going on, because space and defense tech is clearly hot, but this is not just that category. It's all categories in the market right now. I mean, you can actually have devices that are highly intelligent, and you got to engineer them. I mean, AI is not going to just build the code. Hardware is harder. Physics is involved. Materials.
Yeah. There's a lot to talk about there. Yeah, I mean, we're definitely seeing this. I mean, I do think Revel could have been founded at any time in the last decade and been successful, but there's been so many new companies founded, and our strategy has been to try to work with the best in each category. So satellites, working with K2 and Impulse Space. We have a couple defense companies we can't quite announce yet. They're very fast moving and scaling quickly. Hypersonic jets, working with several companies there. And then even small modular reactors. We're actually doing the command and control system for several of the companies in that space. And then what's really interesting, I think the larger companies were starting to engage with some of the more traditional kind of commercial aviation suppliers. And I think they are also looking at what has happened with, at Anduril and SpaceX and similar companies like that, and how quickly they're moving. And they're wondering, well, what is going on here? How can we also take advantage of all the new tools that are available and the new ways of doing things?
Is there a democratization angle here? Because one of the things that mostly was restricted to high IQ, PhDs,
Hmm.
mechanical engineering. You mentioned you got a CS degree. The specialty of building things, you know, doesn't scale, right? If you can't open it up, and also the role of more people are involved in these integrated systems. You got technicians, you got stakeholders.
Yeah.
How is that impacted? How are you seeing that impact your business?
Yeah, it's. I think that really what's changed in the last couple decades, along with the approaches, has been the expectation on engineers. I think back in the 80s and 90s, uh, you really had specialist engineers that were kind of, even just for testing, you have to do the setup, you have to do the configuration, you have to make the interfaces that you view these systems through when you operate them. You have the people that write the control software, you have the people that do the data reduction and the analysis at the end. What we're seeing is that you know engineers today, and they actually want this too. I mean, I wanted this as an engineer. I wanted to be as self-sufficient as possible. I wanted to be able to do all of it. I didn't want to have to go tag in a friend and have them come in and do the thing. I'd explain everything that they needed to then do their job. If an engineer can do all of that, you unlock a massive amount of efficiency and capability, and really just supercharge the talents of that engineer. And that's really what our platform is trying to do as well. um, and I think it's really like engineers are really becoming more like Swiss Army knives. It's not, there used to be like very specialized. You have to go into a particular part of that workflow and specialize in it and then do that across many different systems. Whereas now I think, mechanical engineers can write code.
Yeah.
Like that is now just the expectation. It's not that the mechanical engineer does the mechanical things. It is that they can do a broad spectrum of things, and then that engineer can take a project fully from 0 to 1. They don't have to then hand it off to someone else, which then has a huge context switching penalty, and you have to get this other person fully spooled up on what needs to be done. This one person can take it all the way from kind of start to finish.
How about the impact of digital twins, for instance? We've heard that being a huge accelerant for design,
Mhm.
testing, and accuracy.
Yes, I mean, I actually worked on simulation at SpaceX. The first thing I did, it was a massive part of how SpaceX launched its first shot as well. We would simulate everything and then test all the software against that. And I think this is generally what's going on. I think there's a trend kind of much greater than SpaceX leveraging simulation capabilities, because you can get many more test iterations. If you have a physics model of a system and you can test all of your software against that, you can do it, let's say, 1,000 times, overnight, and go and see what the results are. So we are also leaning in this space. We should have some announcements soon. But no, you're 100% right. The simulation capabilities are extremely exciting
Yeah.
that have been developed and that are coming out.
So we got a little teaser there from something coming. I can imagine what it is, connecting the dots in my head. Talk about a company, the origination, where you guys are now. You guys had a big financing. What stage are you?
Mhm.
How many people are there? What are you looking to do? Obviously, hiring certain types of people. Put a plug in and give a status on where you guys are at.
Yeah, we we did take a big funding round. I think our philosophy, we are very high conviction on what we're doing in this space. I mean, I was at SpaceX for 9.5 years. That was like the ultimate proving ground of software for hardware. And we know exactly what needs to be built in this space. It's a whole ecosystem of products. And taking this funding earlier rather than later, it's kind of money now or money later in our eyes,
Yeah.
will let us double down on the spaces that we want to. We're obviously going to be very efficient, and we are SpaceX programmed to being very very efficient with our resources. Um, but instead of like dragging this out and like doing a fundraise every 2 to 2.5 years, our philosophy is if it's available, let's take it, and we will deploy the capital in the way that we think gets us to the finish line
Yeah.
as soon as possible.
And what's the total raise you guys have now? Totally raised in.
We've raised 180 million so far.
All right.
And yeah, we've been
Congratulations.
we actually just crossed we just crossed a year and a half in the beginning of April.
Yeah.
Yeah.
Yeah, I mean, you're the classic Silicon Valley rocket ship. I mean, literally, you're building rockets. I got to ask you about the trend that we're tracking because it's super relevant, but it's also very cool, and that is the idea of data centers in space. So we've been having a
hmm
conversation around things don't have to be on the ground. There are benefits for certain things in space. Like people are talking about data centers in space. Well, if we need data centers, there's advantages in space, but there's a lot of unknowns. Again, this would be in your wheelhouse. So I have to ask you, if we were going to build data centers in space, what would you advise me to do? How would you approach that?
I would advise, I mean, anyone that wants to build data centers in space, we're already engaged with a few companies doing that. We can accelerate their progress dramatically for all the testing they need to do on the ground.
Yeah.
So I think that would be my recommendation is, I mean, it's definitely a race in this space. We've talked to a number of companies that are pursuing it already. Um, and yeah, I think
There's benefits, but there's a lot of testing, simulation. It's hard to do break fix in space, isn't it?
it is, and yeah, and this is the world that we lived in at SpaceX. Like I think there's only you can do a lot of testing. The more testing you can do on the ground, the more successful you are
Yeah.
going to be when it's in flight
Yeah.
and in space. But yeah, I think it's a super exciting area. I think just working with Elon, I think he's definitely run the numbers on this, and there's a lot of kind of doubts of potentially, but I think Elon's. If he's making this big of a bet in the
Yeah.
space, it's probably a good one.
Well, space has unlocked a lot of things we love. I mean, GPS, you got communications is booming. So, I'm not. It's not far fetched. I mean, it might be a little bit out there, but if people are complaining about data centers in their neighborhood or their town or pressure on the grid, it reminds me of the old cell phone towers. No one wanted one decades ago, but now everyone wants mobile phones, right? So, data centers have to be somewhere, built by somebody.
It does remind me. I mean, I think there were similar questions about Starlink. We all read the book on the Iridium constellation that went up and kind of the issues there, and SpaceX went after it anyway. Um, so I just kind of pattern match and see that people doubted Starship, doubted rocket reuse, doubted Starlink, and look at where those things are today.
Yeah, I mean, look, we couldn't have foreseen the internet and everything else coming. We were kids. I remember when I went to go to the library and take out encyclopedias to study. Look where we are now. I think space is a frontier. Certainly, that's got a lot of unknowns, but a lot of unlocked potential. I love what you're doing, and I think this software for engineering, the tooling, and the platforms coming out to accelerate kind of the building of physical things is a huge deal. Congratulations, and looking forward to keeping in touch.
All right, thank you so much.
All right, Scott Morton here, the CEO of Revel. Making it happen and building physical things with AI faster. Look at SpaceX. You look at some of the success. A lot of naysayers throwing water on that. Data centers in space, a lot of things going on. Again, tech is driving the agenda. Technology is the market. We're doing our job here at theCUBE in Palo Alto, here at the NYSE. Thanks for watching.